Picture this. You're driving to an important meeting when suddenly your GPS goes dark. No big deal, right? But then you notice something terrifying. Traffic lights aren't working, ATMs are offline, and even cell towers are down. This isn't science fiction. It's what happens when GPS fails. What most people don't realize is that a device smaller than your smartphone, costing just 50 bucks, can bring down the entire GPS network for miles around. Right now, there's a hidden arms race happening in space, and the winner will determine whether our hyper-connected world survives the next decade. GPS isn't just about finding your way to Starbucks anymore. It's become the invisible nervous system of our entire civilization. Every time you swipe your credit card, that transaction is time-stamped using GPS. Power grids across continents stay synchronized through GPS signals. Even your smartphone's internet connection depends on GPS to function properly. We've built our entire digital infrastructure on a foundation that's surprisingly fragile. The system that guides billion-dollar military operations can be disrupted by a trucker trying to hide from his boss. That's not just inconvenient, it's dangerous. Here's the fundamental issue that engineers have been quietly worrying about for years. GPS satellites orbit over 12,000 miles above Earth. By the time their signals travel all that distance to reach your phone, they're incredibly weak. So faint that they can barely penetrate buildings or even heavy cloud cover. This weakness makes GPS ridiculously easy to disrupt. Those cheap jammers I mentioned, they work by simply broadcasting a stronger signal on the same frequency. It's like trying to have a whispered conversation in a crowded restaurant. The slightest interference drowns out everything. The Ukraine conflict turned this theoretical problem into a harsh reality. Russian forces deployed GPS jammers so effectively that American precision missiles became useless. Drone operators had to completely redesign their navigation systems mid-war. What started as a military tactic quickly spilled over into civilian life. Countries bordering Russia reported commercial flights and shipping getting disrupted by GPS interference. But here's what's really concerning. This isn't just a wartime problem. In 2013, a single truck driver in New Jersey accidentally shut down GPS around Newark Airport for hours. Denver International Airport lost GPS for 33 straight hours in 2022, and they never figured out why. The scariest part? GPS jamming technology is getting cheaper and more accessible every year. What once required military-grade equipment now fits in your pocket and costs less than a nice dinner. We're essentially running our modern world on a system that anyone can break. Enter Xona Space Systems, a California startup that's about to change everything. Their solution is brilliant in its simplicity. Instead of trying to strengthen GPS signals from 12,000 miles away, why not bring the satellites much closer to Earth? This month, Xona is launching their first test satellite as part of their Pulsar constellation. Unlike GPS satellites that orbit in medium Earth orbit, Pulsar satellites will operate in low Earth orbit, the same region where Starlink operates. This proximity creates a game-changing advantage. Signals that are roughly 100 times stronger than traditional GPS. Think about what this means practically. Those phone-sized jammers that can disrupt GPS for hundreds of meters? Against Pulsar's stronger signals, their effective range shrinks to just a few feet. The signals are so robust they can penetrate deep into buildings, through multiple walls and floors, solving the indoor navigation problem that has plagued GPS for decades. Xona's ultimate vision involves 258 satellites working together to blanket the entire planet. But here's the clever part. They're designing their system to be completely compatible with existing GPS receivers. This means manufacturers won't need to redesign their products from scratch. They can simply add Pulsar capability to current GPS chips. The company originally started with autonomous vehicles in mind, aiming for accuracy within 3 inches rather than GPS's meter-level precision. But recent global events have revealed an even more critical application. Creating a backup navigation system that's virtually impossible to jam or spoof. While satellites grab headlines, some of the most innovative solutions are happening right here on Earth. Companies like Anello Photonics are revolutionizing inertial navigation, systems that track your position by measuring your own movement rather than relying on external signals. These aren't the bulky, expensive inertial systems from decades past. Modern versions use advanced gyroscopes and accelerometers that are small enough to fit in your smartphone. The breakthrough comes from photonic technology, using light instead of mechanical parts to detect motion with incredible precision. Here's how it works. Imagine your phone could remember exactly how you moved from the moment you left your house. Every step, every turn, every elevator ride gets recorded and calculated. Even if GPS completely fails, your device knows exactly where you are based on your journey. When integrated with GPS receivers, these systems can instantly detect when someone is trying to spoof your location signal. Meanwhile, French aerospace giant Safran is taking a completely different approach. They're developing systems that distribute positioning data through fiber optic networks, the same cables that carry internet traffic around the world. This creates a terrestrial backup that's completely independent of satellites and much harder to disrupt. The beauty of this multi-pronged approach is redundancy. If satellites fail, inertial systems kick in. If jammers target radio frequencies, fiber optic networks keep working. Some experts even propose repurposing SpaceX's existing Starlink constellation for navigation, since those satellites already have the necessary orbital positions and communication infrastructure. Here's where the things get really interesting. Xona's first operational satellite launches this month, but you won't have to wait until 2030 for results. According to their timeline, the system becomes useful with just 16 satellites in orbit, something they expect to achieve within the next few years. This aggressive timeline reflects the urgency of the situation. Every month of delay means more vulnerability for critical infrastructure. Financial markets that process trillions of dollars in transactions daily, power grids serving millions of people, and transportation networks moving goods globally all depend on GPS timing signals that could fail at any moment. The geopolitical implications are staggering. Countries with reliable, jam-resistant navigation systems gain massive strategic advantages. Emergency services can operate effectively even during GPS outages. Military operations become more precise and less vulnerable to electronic warfare. But perhaps most importantly for everyday people, this technology enables entirely new possibilities. Imagine self-driving cars accurate enough to navigate crowded city streets safely. Delivery drones that work reliably in urban environments. Augmented reality applications that precisely overlay digital information onto the physical world. The race isn't just between companies, it's between different technological philosophies. Some believe space-based solutions like Pulsar are the answer. Others argue that terrestrial systems offer better security and reliability. The reality is that we'll probably need both, creating a layered defense against GPS disruption. Whatever approach wins, one thing is certain. The next decade will determine whether our GPS-dependent civilization thrives or becomes dangerously vulnerable. This technology revolution extends far beyond navigation apps. We're witnessing the birth of a new era where precise positioning becomes as fundamental as internet connectivity. The companies and countries that master jam-resistant navigation will dominate autonomous transportation, enable revolutionary augmented reality experiences, and secure their critical infrastructure against increasingly sophisticated threats. The GPS system that seemed magical in the 1990s is becoming the Achilles heel of our digital age. The race to replace it isn't just about better technology. It's about ensuring our hyper-connected world remains functional when the inevitable disruptions come. So, here's my question for you. How many times did you use GPS-dependent technology just today? Probably way more than you realize. As we head into this new era of navigation technology, which solution do you think will win? Stronger satellites, ground-based alternatives, or something completely different? Drop your thoughts in the comments below. If you found this deep dive into hidden technology fascinating, hit that subscribe button because we're covering more breakthrough innovations that are reshaping our world behind the scenes. And remember, the future isn't just happening to us. It's being built by people who refuse to accept the status quo.